Hello and welcome to this video about arc length in non-unit circles. In this video, we're going to look at arc lengths and special points in non-unit circles. We'll start by reviewing the unit circle. We know that the unit circle has a radius of 1 and that a radian is a way to measure angles. Specifically in the unit circle, the measure of the angle in radians is equal to the arc length. So we could say that this arc length is theta because the central angle forming that arc is also theta. So how do we determine the arc length in a circle where the radius isn't 1? Let's look at a circle with a radius other than 1 to answer that question. Here we have the unit circle in blue and the green circle with a radius of r. One thing we notice is that the central angle, theta, is the same in both circles. In the unit circle, we know that this arc length will also be theta. But because the radius is not 1 in the larger circle, and even just looking at that larger circle, we can see that the arc length is not going to be equal to the angle measure theta. So let's use the variable s to represent the arc length on the bigger circle. S is just the standard variable that mathematicians have chosen to represent arc length. So what is the arc length on this larger circle? Although these are not triangles, we do have similar shapes called sectors. We can actually set up a proportion just like we would with similar triangles to help us see how the radius and the arc length are related in the bigger circle with radius r. We can look at corresponding sides of the sectors, namely the radius and the arc lengths, and so we can say that 1 over theta equals r over s. To be clear, we are using corresponding sides. So when we write theta in this proportion, we are referring to the arc length on the unit circle. Remember, we're trying to determine the arc length of the larger circle. So it would be nice if we can isolate s in this proportion that we wrote. So if we cross multiply, we would get 1s equals r times theta, and this formula would simplify to s equals r times theta, and it tells us that given any size radius, the arc length is the radius times theta. Keep in mind, we were viewing theta as the arc length in the unit circle, but we also know that theta is equal to this central angle in both circles, measured in radians. So in conclusion, what we have really found is that given any circle size, the length of an arc is the radius times the central angle measured in radians. Another way to think about it is like this. If we enlarge the circle by a factor of r, then the corresponding arc length is also r times bigger. In the next video, we're going to practice using this formula for arc length in circles of any size. But before we do that, I also want to remind you that when we're on the unit circle, we can think of points that lie on the circumference of the circle and are located at coordinates x, y. So this coordinate of that point would be x, y. And when we enlarge the unit circle by a factor of r, then just like the fact that the arc length is r times bigger, the same thing is going to happen to this point x, y. The horizontal distance is going to increase by a factor of r, and the vertical distance is also going to increase by a factor of r, making the coordinates of this point on the larger circle xr, yr. Now we should be ready for the next video where we will look at some examples of how to use what we just learned in non-unit circles.